Okay, we're going to start a unit on vectors, and first thing we're going to look at is some vector operations. Basic skills you need to have when you talk about vectors. So here's our friend Vector from Despicable Me who will accompany us through this unit. Okay, so first of all, what is a vector? Okay, a vector is a quantity that has both magnitude and direction. The magnitude could be a speed, it could be a force, multiple things. Usually a speed, but it's going to also have a direction that it's going in. Okay, so when you have a vector, you're going to have these things right here: an initial point, a terminal point. Initial point is where it starts. Terminal point is where it's going to stop. Okay, and that will help determine the direction. The horizontal component is just like what you would think when you graph. It's like your x values. These are your x's, right? The vertical component is this, the vertical distance. Okay, and then notation. There's different notations you're going to need. A vector could be written like this. A component of a vector is written like this, v1, v2. I'm going to show you how to find the component of a vector. But what you have initially is an x1, y1, an x2, and a y2. Okay, it's important that you recognize which one's the terminal, which one's the initial, because that will determine your component. All right, to find the component form of a vector. If the initial point is x1, y1, and the terminal point is x2, y2, then the component form of the vector is x2 minus x1, y2 minus y1, yielding a vector that looks like this. Notice the v's on the side. This means component form of v1, v2. That's the horizontal, that's the vertical. So instead of having 2 points, you're converting it basically down to 1 point. That is a vector that can be drawn from the origin instead of out in outer space. It's just drawn from the origin straight to wherever you calculate it. All right, so let's try this. If the initial point is -3, 5, terminal point is 2, -4, write the component form of the vector. This is my initial, this is my terminal. If you catch nothing else, remember it's the terminal minus the initials, okay? So terminal x is 2 minus the initial x, which was -3, so it's a +3. Terminal is -4 minus the initial, which is 5. So 2 plus 3 is 5. -4 minus 5 is -9. So this is the component form of my vector. Okay. All right, calculating the magnitude. This is finding the speed of the vector. Remember, if your initial point is x1, y1, and the terminal is x2, y2, then the component form is what we just did. Subtract the x's, subtract the y's, and there's your component vector. Well, v1 is your horizontal component because you got that from subtracting x's, right? v2 is the vertical component because you got that from subtracting the y's. Well, look at that. You have a right triangle. So in order to find the magnitude, you would use good old Pythagorean theorem. Okay, nothing new about that. So v1 squared plus v2 squared equals c squared, or your magnitude squared. Or v1 squared plus v2 squared equals the magnitude, and magnitude looks like this. Okay, now I don't want it to be equal to magnitude squared, so I'm going to take the square root of both sides. Okay, but do the addition first, raise to the exponent first, add them up, then take the square root. All right, example 2. If the initial point is 2, 7, the terminal point is 1, -3, write the component form of the vector and its magnitude. Okay, so component form first. Remember, terminal minus initial, 1 minus 2, -3 minus 7. So that means my component form would be -1, -3 minus 7 is -10. So there's part of my answer. Now for magnitude, I'm going to take my component form, -1 squared plus -10 squared. That's 1 plus 100. So I get a square root of 101, which comes out to 10.0. Remember to keep a 0 as a placeholder when you're rounding to the 10th place, unless it's a perfectly round number. All right, to calculate the angle of direction, Using your component form of the vector, you can find the angle of direction using inverse tangent. Because remember, component form This is your x and this is your y. Remember, tangent is always the y over the x, right? So we're going to utilize that relationship to find our angle. Let's look at this. Here's some steps for you to follow. Okay, first, you're going to draw a reference triangle in the correct quadrant. Put theta in the triangle. Use inverse tangent to find your theta. And then we'll talk about step 4 here in a moment. Let's just do this first, on number 3 here. Find the angle of direction of the vector, given this. Now, the v's on the outside here, instead of parentheses, means it's the component form. So where would negative 5, 3 be? Well, that would be over here. So here's my vector, right? Theta in the triangle, always at the origin. And see, negative 5 and 3. Well, the inverse, or the tangent of theta, is always the opposite over the adjacent, right? Well, opposite is 3, adjacent is negative 5. Now, I don't want the tangent of theta, I want theta. So I'm going to take the inverse tangent of 3 over negative 5, and that will give me my theta. When I do that, I get an angle that says negative 30 point, or do negative 31.0, okay? Okay, so that is my angle. Well, don't let the negative flip you out. It's just, take the negative off. In fact, think of that angle right there as 31.0 degrees, all right? Now, that is not my answer. My answer has to be an angle that is measured from standard position. Remember, standard position starts here, and it's going to end wherever your vector is. So it's going to end here. So it's this angle right here. That is my actual answer. So in order to do that, you need to remember, okay, this is 180 degrees over here if it went all the way around, right? Doesn't quite go that far, so I'm going to take 180 and I'm going to subtract 31.0. When I do, I get 149. That is my answer, okay? So make sure you answer in standard position of the angle. Now, what does that mean? Sometimes you're going to add, if it's in, let's think about our quadrants. If my triangle is in quadrant 1, then theta is what theta is. You don't have to add or subtract anything. If my triangle is in quadrant 2, then I'm going to take 180 and subtract my theta. If my reference triangle is in quadrant 3, so it starts over here, it has to go all the way around. So over here I'm going to do 180 plus theta. And lastly, if it's in quadrant 4, that's this angle here, I would do 360 minus theta. Okay, I hope that helps. You should be able to see the relationship and figure this out as we go. Okay, all together now. If the initial point is at negative 4, 6, terminal is at 5, negative 9. Write the component form. There's step 1, magnitude, step 2, and angle, step 3. All right, component form first. Remember, terminal minus initial. So 5 minus negative 4, negative 9 minus 6. So I get 9 and negative 15. So there's my component form. For magnitude, I'm going to take the square root of 9 squared plus negative 15 squared. And when I do, I get 17.5. Now angle, I take my component form and graph this. X is positive, y is negative. So that means my reference triangle is down here. This is 9, this is negative 15. So when I do inverse tangent, it's always the y over the x. And that'll give me my theta. Point 0. Okay, so remember, take off the negative. So this angle in here is 59, but I need the angle that is measured from standard position that comes all the way around. So what I'm going to do is take 360 and subtract 59 degrees, and what do I get? 301. So that's my angle. All right, I hope that makes a little bit of sense. All right, I want you to try this one on your own. It's just like what we did with initial and terminal ends. Find the component, find the magnitude, and the angle. Good luck, and we'll see you in class.